Okay, this video we're going to be doing examples of solving systems by elimination. So remember, elimination means to get rid of something. So your goal here is to look for a variable that has the same coefficients and then opposite signs that you can add or subtract to get rid of. So in this example here, I have a 5x and a negative 4, and I have a positive 3 and a negative 3y. So if I come up here and if I add these two together, these equations here together, 5x plus a negative 4, remember signs are opposite, you're going to subtract. So I'm left with x, and then a positive 3y plus a negative 3y is 0. So then I'm going to have 14 plus negative 7 gives me 7. So now I have a value for x, so I can go back into either equation and substitute this value. Okay, so 5 times 7 is 35, plus 3y equals 14. Okay, so now I'm going to subtract 35 from both sides, and I'm left with 3y is equal to negative 14, positive 14 minus 35. Signs are different, so subtract. Keep the sign of the larger number. So this is going to be negative 21. Divide by 3, and I get y equals negative 7. So my answer here is x is 7, y is negative 7. Remember to write as an ordered pair. X always comes first and then y. Okay, my second example here, I'm looking for the same coefficient. So notice my y's have 4s, but they're the same sign. So when my coefficients are the same sign, I need to subtract. So I'm going to subtract this equation. So what happens here is negative 5. We can distribute this negative. This becomes, I'm going to add the opposite and change my signs. Okay, so negative 5x plus 2x becomes negative 3x. Positive 4y plus a negative 4y is 0. Negative 19 plus 10 becomes negative 9. Going to divide by negative 3. Divide by negative 3, I get x is equal to 3. Okay, so my next step is to go back and substitute it into one of the original equations. So I have negative 5x, so I'm going to put 3 in for x, plus 4y is equal to negative 19. Negative 5 times 3 is negative 15, plus 4y equals negative 19. Add 15, I get 4y equals negative 4. Divide by positive 4, y is equal to negative 1. So my solution here would be 3, negative 1. Okay, in this example, I'm noticing that I don't have variables with the same coefficients. So this is when you would need to multiply. So I can multiply the top or the bottom, either one, to get rid of my x's or y's. So if I multiplied the top by a 2, okay, so if I did that, I wind up with negative 8x plus y equals 22, and my second equation says 8x plus 2y is equal to 22. Alright, so now I notice I have my coefficients here. The x has the same values, but the numbers are the same, so when they're same, you're going to subtract. So then I'm just going to change the sign of each one here. Negative 8x plus 8x is 0. I forgot to multiply this by 2. So 2y minus 2y is 0, and this is 0. So notice I get 0 equals 0. So I did this problem as an example. Whether you're doing this type of elimination, substitution, or just adding, subtracting elimination, anytime you get the same sides, you get both sides of the equation equal to each other, you should know you have infinite solutions. So this doesn't matter which way I solve this. If you get both sides equal, it's an infinite number of solutions. Okay, my next example here, we're going to notice that I don't have any variables. I have 6x plus 12y, and the second equation is 3x plus 6y. So I don't have any equations here, or any variables, I'm sorry, that have the same coefficient. So I need to multiply this by a2. So this becomes 6x plus 12y equals negative 12. My top equation stays the same. It's negative 19. So now my variable x, my x variable has the same coefficient, so I'm going to subtract. Okay, so that means I'm going to change the sign of each one in here. Okay, 6x plus negative 6x is 0. 12y plus a negative 12y is 0. And then negative 19 plus 12 is negative 7. So come down here, equals 0 equals negative 7. So whenever this happens, when I have the equations not equal to each other, this is when you have no solution. Okay, this is when you're going to have a parallel line. Okay, so there's no solutions on that one. And I did this example so that you could see the two differences. Remember, when you get them equal to each other, it's infinite number of solutions. When they're not equal, it's no solution. Okay, if you have any other questions on solving by systems by elimination, please see me in class.